Hello, good morning. My name is Mohiuddin Ahmed, and I am here for my presentation for the course ENGI 9857 Spring 2024, and my project topic is analysis of DVR performance for minimizing voltage shifts through simulation by using PI and fuzzy logic control. And the supervisor of my project is Dr. Mohsin Jamil. Here is the outline of my project. First slide, I will describe the introduction, then literature review, then simulation, then a result analysis, then conclusion, then I have some recommendations for the improvement of the project. First of all, introduction. Here I am talking about power quality, and it is very important issue because of its consequences for electricity suppliers, equipment manufacturers and client. IEEE defined the standard. Power quality is meant as the ability mode a technique in which power is supplied and connected to the electrical equipment required for its functioning, about the wiring system of the premise and the other connected electrical devices. Here is the literature review. First of all, a continuous voltage disturbance such as voltage shifts and sales may result in damage to the hardware as well as the system's crash and the utilities and customer cost. The table besides show the IEEE standard for the damages such as like type of disturbance, voltage shifts IEEE 1151, voltage 0.1 per unit to 0.9 per unit and limit its 0.5 to 1 minute, and harmonic IEEE 591, voltage should be less than 69 kilovolt and 3% IBH and 5% TST voltage. And here I will use DVR to minimize these problems. And DVR is a type of custom power equipment, and because of its features, it can effectively deal with the voltage sag issue. Here is my methodology for the simulation and the result analysis for the project. I will use MATLAB Simulink, and in this MATLAB SQL Simulink software, I will design and model a three-phase distribution network. And here is the flow chart of the project. First of all, start, then identify the project, then literature review, then test system modeling, design the DBR based on study, run the simulation. If voltage is removed, then I should go to the analysis result and final report. If doesn't remove, then I will again design the DBR based on my study, then the end and simulation. Here I have shown the main schematic diagram of my distribution network. Here you can see that I have used three-phase supply, three-phase transformer, three-phase circuit breaker, and three-phase parallel RLC load for my project, and here I have also used phase to ground fault so that I will create a fault manually. Then I will try to resolve the issue by using DVR. Here I have attached my DVR, and here is the detailed diagram for the DVR. Three-phase breaker, RL circuit, RLC circuit, and bus 3. Here input voltage will be injected by the DVR, and I have used two-level converter, and I have used also series RLC branch. And here is the details of my three-phase transformer. It has 12 terminals. And here is the control circuit for the DVR. Here I have used PI controller, and here is my result analysis. When the fault occur between phase and C, the result will the graph like this, and phase A and C only, that means line to line fault. And when the fault between phase A, B and phase C only, all phases, then the graph will like this. And result analysis for the voltage sag mitigation. And the previous slide was for the voltage sag generation, and here the slide for the voltage sag mitigation. Here we have clearly seen that all of the voltage sags were clearly removed, and the voltage sag happened 0.04 seconds to 0.9 second, and this is the graph for the during single line to ground fault. And here is the result for the during double line to ground fault, and here is the during three phase to ground fault. Everything is shown here, like voltage source, load voltage, injected voltage, and RMS voltage also shown in the second graph of this slide. And here is the result for during line to line fault, and this is the during the three phase fault. And here is my summary of my result, like when the fault occur in the single line to ground, then the V volt VA is equal to 1, VB equal to 0.5, BC equal to 0.1, and the result after injected all of the voltage reached to 1, and all of the voltage are measured in per unit. And conclusion, finally the conclusion is the project was based on research work that focuses on finding the best solution for voltage sag or voltage cell. And in this project, the impact of voltage sag conversion of three-phase symmetrical and unsymmetrical fault are conducted. And here is my some recommendations. The other option way is to incorporate higher power electronic devices such as active clamp filter, statcom, GAN switches, including flexible AC transmission system devices and some other power electronic devices or compensator. To enhance the result of the project, capacitor bank can be installed in parallel with the load to improve the power factor, and this PFI can also be performed by implementing flyback converter.